So today we're talking about finding the area between two curves. So we're going to move on to section 6.1 in your notes. Like I said, you will need a calculator today, so if you want to go ahead and grab that. If you don't have yours with you, you're welcome to borrow one of mine from the front here. So when you're trying to find the area between two curves, let's say I give you an example like this. So this is 6.1. And let's say I give you, if you'll leave a little space in your notes there, we'll come back and write down the formula that we'll need. But for the first example, I'm going to ask you to find the area between f of x equals x squared minus 4x plus 3 and the function g of x is negative x squared plus 2x plus 3. Find the area between those two curves. So we're going to start by graphing those two curves on our calculators. I'm going to pull up my 84 here. While you're typing in those two functions.
What was the second function? I didn't get to finish writing it down.
Negative x squared
Negative x
plus 2x.
2x plus 3. Okay, thanks.
Explain that. Yeah. It's a mess.
Okay, so in y sub 1 you should have typed in your x squared minus 4x plus 3. And then in y sub 2 it's negative x squared plus 2x plus 3. And I pulled up this simulator because I wanted you to see the two different functions. The first function will be graphed in blue, and then the second function in red. I'm going to do zoom 6 to start out in the standard window. So there's my f of x function, and then here comes my g of x function. And so what we're learning to do today is to find the area bound by those two curves. So this is another really, really powerful concept that calculus allows us to do. Hey. Okay. If you look at the red graph, our g of x, and then the blue graph, our f of x, what we're going to be finding is the area bound by those two graphs. What is it? Like that?
Mhm.
That's all right. So you're talking about the form that looks just like this. Now mine was with mine. Did you feel because mine was the first change. Mine was just the first page of that report. All right, so again, we're finding the area bound by those two curves. And there we go.
How do we do that?
And what I was saying is this is another really powerful concept that calculus allows us to do, if you really think about it, because in geometry we know how to find the area of a triangle or a square or just basic shapes, but with calculus we can really find the area of any shape as long as we know the equations for the borders of that shape. Isn't that cool?
Super cool.
It's awesome. That's powerful. So the formula that we're going to use to help us find the area bound by two curves is we're going to use integration. We're going to use the antiderivative. And what we're going to integrate is we're going to integrate the top curve that borders the area. So in this case, our top curve is the red curve, which we said was g of x, I believe. Parabola that opens down. And then you're going to subtract the bottom border, which happens to be f of x. And you're going to compute a definite integral. So your bounds are going to be the leftmost intersection point is going to be your bottom bound, the A. And your rightmost intersection point is going to be your top bound, the B. So let's write that formula down in our notes. And then we'll go back and compute it. So to find the area between two curves, you're going to take the antiderivative from A to B of f of x minus g of x dx. Now, when I say f of x minus g of x, I need to clarify a little bit. Because in the example that I gave you, it's not actually going to be f of x minus g of x, it's going to be g of x minus f of x. Because the first function is always going to be the top bound, whichever one is on top. And then the second function is going to be the bottom bound. So over here to the side, I want you to write down that f of x is considered what we call the top equation, and g of x is the bottom equation. And then I want you to write that A is the left intersection point. Well, it's actually not a point. It's the x value. The left intersection x value, and then B is the right intersection. And again, both of these are x values. The bounds are always x values. So once you get your formula copied down, we'll go back to example 1 and actually compute the area between those two curves. Anybody still writing before I scroll up? Okay. So I'm going to start off by setting it up to be the integral. I haven't found my intersection values yet. We'll go back and do that here in just a minute. We said our f of x function is going to be our top equation, which in this case our top equation was g of x, wasn't it? So we're going to write inside parentheses negative x squared plus 2x plus 3. And then we're going to subtract off the bottom equation, which in our example happened to be f of x. x squared minus 4x plus 3. Now the parentheses are really important because we're going to have to distribute that negative to the second parenthesis. Now let's go back to our calculators and let's find the intersection points so that we can list our bounds. Okay, so we're gonna go, now I'm on my 84 just because I thought it was, we would be able to see in color the two different graphs. You're probably using your 89. So I'm gonna show you real quick on the 84 and then I'll project my 89 up here too, in case you don't know how to find the intersection points on there. So on the 84, if you're using that calculator, you're gonna go to second trace and choose number 5, intersection. And then I'm just going to hit enter 3 times. Notice that my cursor is closest to the leftmost intersection point, so I don't need to move it. So I hit enter 1, 2, 3 times. The first time locks in the first curve, the second time locks in the second curve, and the third time tells my calculator, hey, find it. And so the intersection point is the point 0, 3, we just use the x coordinate of that intersection point. So our lower bound is going to be 0. And now let's find our upper bound by going to second trace, choosing number 5 again. But this time I need to move my cursor closer to the right intersection point so that my calculator knows which one to find. Otherwise it'll just find the left intersection point again. Hit enter to lock in the first curve. It's telling me where is the second, or asking me where is the second curve. Hit enter again, and then I hit enter one last time, and the intersection turns out to be 3, 0. So my bounds are going to be from 0 to 3. If I go back to my formula here, I'm going from 0 to 3, the intersection point, the x values of the intersection point. I also wanted to show you on the 89, for those of you using the 89, if you go to your y equals, let me type in my function, or my functions. I know it's harder to see this one, but I'm going to type them in real quick and just walk you through it. So here's my g of x function is graphing first, and my calculator dies. Can I borrow someone's 89 that has it typed in? Thank you. All right, so here are the two functions. And so you can go to F5, which is the math menu, and it's also number 5 in here. And then you're going to hit enter twice, once to lock in the first curve, another time to lock in the second curve. But notice now it's asking me for a lower bound. That means left bound. So I'm going to move my cursor a little bit to the left of that intersection point and hit enter. And then upper bound means right bound. So I'm going to move it to the right of the intersection point and hit enter. And it still gives me the intersection 0, 3. So you have to lock in the two curves and set bounds so your calculator knows where to look for that intersection point. Yes?
My 89 also has got it.
Okay, I'll get us some batteries here in a minute, okay? All right, let's do it one more time. F5 is the math menu. I'm doing number 5, intersection. I'm locking in the two curves by hitting enter twice. For my lower bound, I'm just going to get a little bit closer to that second intersection point, but to the left of it, hit enter. upper bound, I'm going to the right of that intersection point. Notice that an arrow pops up when I hit enter. And so it's the 0.30. So I'm using the X values from those intersection points for my bounds. The leftmost intersection point is your lower bound. The rightmost intersection point is your upper bound. Any questions about finding the intersection on the calculator? Thank you. All right, well, let's finish this out here. We're going to take the integral from 0 to 3. And to save me some writing, I'm going to go ahead and distribute my negative and combine like terms all in one step. So this is going to be plus a negative, positive, negative. If I distribute the negative to the second parenthesis, and when I combine like terms, I get negative 2x squared plus 6x, and I think my 3's cancel, huh?
Yeah.
Okay. And that's with respect to x. And so now we take the antiderivative. So what is the antiderivative of negative 2x squared? Negative 2/3 x cubed, or negative 2x cubed over 3, plus the antiderivative of 6x,
Which is 3x.
3x squared, good. 6x squared over 2, which reduces to 3x squared. I'm not going to write plus c because this is a definite integral that I'm evaluating from 0 to 3. I'm going to use my fundamental theorem of calculus, and I'm going to sub in my 3 first. Then I'm going to sub in my 0. I know that second parenthesis goes to 0, but my first parenthesis, let's see, I'm going to have a negative 2 times 3 cubed is 27. So negative 54 over 3, which would be negative 18. Plus 3 times 3 squared, well 3 squared is 9. And 9 times 3 is 27. What's negative 18 plus 27? 9. And now I would like for us to check our answer using our calculator. So we're going to type in, I'm going to show you how to do it on the 84 and the 89. We'll start with the 89, since most of you are using an 89. I am having bad luck with calculators today. All right, I think this one's gonna work. Okay, so we are going to go to go to your home screen first of all, and then go to F3, number 2. F3, number 2. And you're going to type in, open parenthesis, negative x squared. We're going to type in that first line there.
Can we not just do the one that's put together?
I'd rather you go back
Okay.
in case you made a mistake. I'd rather you go back to the very first line because you could have easily made a mistake in combining like terms.
Okay.
So negative x squared plus 2x plus 3 in one set of parentheses then minus, open a new set of parentheses. I'm going to zoom a little bit so you can see it better. And then type in x squared minus 4x plus 3. Close that parenthesis. Then you're going to need a comma. The comma is right to the left of the division symbol. So you need to tell it what to anti-differentiate with respect to, and that's going to be x. Then you need another comma with the lower bound, which was 0. Another comma with the upper bound, which was 3. And then close your parenthesis. So that's the syntax for the 89. And then if you hit enter, it should spit out 9, and it does.
I get negative 9.
Negative sign wrong and
So that was the 89. Let me flip over to the 84. And if you're doing it on the 84, you want to go back to the home screen. You want to go to well, this has a few more functions than my 89 has on it, or my 84. But if you go to Alpha Window, choose number 4. It sets it up for you, and you can just type it in exactly how it appears. So Alpha Window number 4. So you type in a 0 as the lower bound, 3 as the upper bound. Then you're going to type in your function, and it should spit out. I'm not going to, it'll take me too long to type all that in. You guys can get it from here, yes? Okay. So I'm asking you now to check, especially for tonight's homework, to check using your calculator to get some more practice using your calculator doing integration, because if this question were on the calculator portion, I want you to just type it in here and not even do all this. You just type it in your calculator and get positive 9. So for tonight's homework, I do want you to work it out, because it could be on the non-calculator portion. But I want you to then go back and check it using your calculator so you can get some practice with that. The other thing I wanted to say is, if we didn't have a calculator, or I wanted to ask you, if we didn't have a calculator, how could I find the bounds? What? I can't hear you. I hear some people talking, but I can't really hear what you're saying. Is it, so what equal to 0? The what? Close. You actually only need one equation. You set the two equations equal to each other.
Oh, okay.
Oh. Right? So you would set your x squared minus 4x plus 3 equal to the negative x squared plus 2x plus 3, and then solve it for x. That's how you would find it without a calculator. That's only if it shows up on the non-calculator portion, by the way. So let's make a note of that. If you will put on here non-calculator to find intersection you set the two equations equal to each other. To find the intersection points, you set the two equations equal to each other, and that will give you the x values. If you set those two equations equal to each other and solve for x, it'll give you two answers. It's a quadratic. It'll give you 0 and 3. All right, let's try another example. Anybody still writing before I flip the page? All right, number 2 is, I'm going to give you the two equations. F of x equals 3x cubed minus x squared minus 10x. And g of x is going to be negative x squared plus 2x. Now normally if they give you something like this on the non-calculator portion, it will either be two equations that you could easily visualize what the graph looks like on number 1. I think all of us could look at number 1 and tell that f of x is a parabola that opens up and g of x is a parabola that opens down. Or if it's something like this that you may not be able to visualize as easily, they would give you the graphs, and then you would just need to distinguish between what a cubic graph looks like and a quadratic graph looks like, which again I think you guys would be able to do fairly easily. All right. But if we don't have the graphs, we're going to start off by graphing it. So I'm going to go back to my 84 so I can get the color option. I'm going to clear this out, go to y equals, and I'm going to type in 3x cubed minus x squared minus 10x into y sub 1. And then in y sub 2, it looks like I just need to delete the plus 3. Okay, let's graph it. I usually start out in the standard window. A little more interesting than number 1. What are we finding again? The bounded area, the area bound by these two curves. How many areas do you see? There are 2, right? This area here is bound. By the way, which one's the cubic and which one's the quadratic? Blue is the cubic, red is the quadratic, okay? And then does everybody see this area here is also bound by those two curves? The problem, well, not really a problem, but notice that this area, the top curve is actually the cubic, the bottom curve is the quadratic. But if you look at the second area, the top curve is the quadratic and the bottom curve is the cubic. That's actually no big deal because all we're going to do is we're going to find the area of this piece and add it to the area of this piece. So it's almost like doing 2 problems in one. We'll do 2 separate antiderivatives. Okay, so let's get going. Actually, you want to go ahead and find intersection points too? I think that will help us out a little bit. So let's do this. Let's do this side of the room. I want you to find the leftmost intersection point. middle of the room, I want you guys to find the middle intersection point, and over here, if you guys will find the rightmost intersection point. Just the x coordinate. Okay, so for our first piece, we're going to do the integral from, what's the lower bound? -2. Okay, so -2. So this intersection point here is -2. Middle group, what's the middle intersection point? 0. So -2 to 0 are my bounds for the first piece. Is my top equation f of x or g of x?
Is that?
Yeah.
Which one's that one?
That's what I meant. I don't know why I thought the cube one was.
Yeah, this is my top curve, so it's going to be f of x. So I'm going to write that one down first, 3x cubed minus x squared minus 10x. And then I'm going to subtract the bottom curve, which is negative x squared plus 2x inside parentheses, dx. I'm going to figure out that answer. Yes?
Why would you pick -2 rather than regular 2? Because they're both intersections, right?
Bottom bound has to be the leftmost intersection.
Oh, wait, bottom bound, never mind. Never mind.
So we're only looking at this piece here now.
Oh.
Okay?
Oh, okay.
And then we're going to add on to that the integral for the second piece. What would be the bottom bound for the second piece?
0.
0.
And the other one.
And the top bound is
2.
positive 2. Good. Okay, what's the top equation for the second piece? G of x, which is negative x squared plus 2x. And then I'm going to subtract off of that my bottom equation, which happens to be the cubic f of x. Okay. So you're going to find an answer for the top piece, an answer for the leftmost piece, an answer for the rightmost piece, and then you're just going to add them together, and that will give you the total area. Okay, let's do this. For sake of time, let's use our calculators. By the way, on homework, I need you to do it by hand and calculator, okay? But for right now, for sake of time, we're going to use our calculators. And I want, if you are sitting on my right side of the room, I want you to do the top integral. If you're sitting on my left side of the room over here, I want you guys to get an answer for the bottom integral for me using your calculator.
Okay.
Just typing it in your calculator. Give me those two answers and then we'll add them together. Anybody need help with their calculator? Oh, let me get batteries while you're doing it.
I did the calculator. Got
Wait. Okay, what are we getting for the first area? 12, okay. And for the other area? 12. So that means the total area is 24. Now, guys, we'll talk about free response questions a lot more in detail over the next couple of months. But if this were on an open-ended question on the actual exam, on the calculator portion, I would not write all this down because it wastes time. What I would do is I would say the integral for